I love synthetic division.
Synthetic division is fun. Now, section 2.3, Caitlin, is going to come in two parts. It's going to come in synthetic division, and it's also going to come in long division. And in this section right here, we have something called the division algorithm, which I'm pretty confident you haven't been told before. Maybe, but I'm pretty confident you haven't, okay? What that means is that if you take a function, f of x, and you divide it by a divisor function, then what you get is you can break the function up into a divisor function times a quotient function plus a remainder function. And I'm going to give you an example of this and hopefully have it make more sense, okay? But this is what you should write down right now. This is the division algorithm. So if you take a function, actually I should get rid of this divided by d. I need to get rid of this. There, equals. If you take a function and divide it by some divisor, then it will break up into a divisor times a quotient plus a remainder. So let me give you an example of this, but let's just go right back to numbers, Sydney. If I take the number 27 and divide it by the number 4, what did we ask ourselves in elementary school when we had to divide 4 into 27? How many times? So 4 goes into 27 about 6 times. That right there, Kate, is called the quotient. That's called the quotient. This is the divisor. Does anybody know what the inside is called again? Dividend. And so we get 24, then we subtract and we get 3, and this part here is called the remainder. That's exactly right. And so function division is going to work exactly the same way, Abby. We're going to have a divisor, we're going to have a dividend, we're going to have a quotient, we're going to have a remainder. The only difference is that instead of numbers, there'll be functions. But the idea is exactly the same. Okay? So, for example, if I have f of x is equal to x squared minus 16, and I want to divide it by a divisor function of x minus 4, well, synthetic division works this way. So we're going to do synthetic division today. Synthetic division, what you do is you set up the synthetic division table, and you start with the numbers. So this is a 1. And what happens is you put a 0 next. And the reason why is because this is x squared plus 0x minus 16. So Abby, you have to have all of the descending powers. Does that make sense? Has anybody not seen that before? If you just have x squared minus 16, you still need to have an x in there somewhere, and the only way to get that x is to have a 0x. So you have to have perfect descending powers in order for this to work. And then finally minus 16. Now, in order to divide it correctly, we're going to take this, and not negative 4, but positive 4 goes here. Okay? Then...
It's always the opposite, right?
It's always the opposite, yep. Then what we do is we drop the first number. 4 times 1. Put the 4 here and add. 0 plus 4 is 4. 4 times 4, 16. And now we get a remainder. This right here, Abby, is our remainder of 0. And whenever we get a remainder of 0, we are happy.
I'm always happy.
We're happy. Kate's always happy. Now, this right here, Kate, this has a special interpretation. 1 and 4 means x plus 4. So what we just did was we broke this up. F of x is now equal to x minus 4. That's the divisor. X plus 4. That's the quotient. And in this case, the remainder is 0, but I only wrote it there once. I'm never really going to write 0 if I have it, okay? So what we just did was, in essence, we factored the function by using synthetic division.
Wait, so would your answer just be x plus 4, or would you have to do x minus 4?
Okay, the answer after dividing this, so f divided by d is equal to just x plus 4. But this answer right here, Sydney, is taking the function now and rewriting it using the division algorithm. So this is d of x here, and this is the quotient, q of x.
That's our answer.
And so this is now the factored form. And Katie asked me, is that the answer? And the answer to her question is, it depends on what you're being asked. Are you asked to rewrite the function using the division algorithm? Then Joshua at the bottom, that's our answer. But if the answer is, what is the quotient? Well, then the answer, Katie, is just x plus 4. So the answer to your question depends upon what's being asked of you. Does that make sense? Okay, so once you know what's being asked of you, then you can do it. Okay, let's do another one. Let's have f of x equals, let's say, 2x squared. Let's see, give me a second. X plus 3, x plus 1, so 3 and 1, x2 plus 5x plus 3. There we go. And let's divide this by 2x plus 3. So there's our divisor function. So we're going to take f and we're going to divide it by d. Okay, so we set up our synthetic. Now, the problem here is this. For synthetic division to work, Caitlin, we have to have an x, not a 2x. So, in order to do this correctly, what we have to do is we have to factor out a 2. X plus 3 halves. Okay?
What happens to the 2?
The 2? The 2 is right here. But I'm going to divide this by x plus 3 halves. See, synthetic division doesn't work unless you have just an x.
Right, but when you put the 3 over 2 over there, like, does the 2 just go away?
It doesn't just go away. What I'm left with now is I'm left with 2, 5, and 3. Does it make sense where I got those? Okay. And here what I do is I put the opposite of this. Okay. Now the 2 doesn't just go away. Okay. Well, let me explain what happens here. Okay. So what happens? Drop the 2. What's negative 3 halves times 2? Negative 3. Put that here and add 2. Negative 3 halves times 2? 0. Now, here's the 2 that you thought went away. Here's the 2 that you thought went away. Right here. So this right here represents 2x plus 2.
So what's your answer?
So we can factor a 2 out of that, right? So that becomes 2x plus 1. Now, again, is that our answer? Well, it depends on what's being asked of us. If we're looking for the quotient, that's our answer. But if we're asked to rewrite the function using the division algorithm, then this is our answer. F of x equals 2x plus 1 times x plus 3 halves. Okay? So it depends, Abby, on what you're being asked. Okay. Actually, let me just type it. If you get a remainder of 0, then you have found a factor of the polynomial. If you found a remainder of 0, then you have found a factor of the polynomial. So let's open up the book. Let's go right to section 2.3, and let's look at some examples here. Here we go. Okay, example 5 is on page 154. That's the remainder. Yeah, I don't think I want example 5. Come on. There we go. Example 6, page 155, example 6. It says here that show that x minus 2 and x plus 3 are factors of the following function. So we set up using the division algorithm, and first we're going to start with x minus 2 as a factor. So we start with 2, 7, negative 4, negative 27, negative 18, and right here, Abby, they drop the 2. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. Negative 4 plus 22 is 18. 2 times 18 is 36. Negative 27 plus 36 is 9. 2 times 9 is 18. Negative 18 and 18 is 0. We've just found a remainder of 0. And that confirms, Caitlin, that x minus 2 is a factor. So that means that this part right here, okay, does everyone see where the hand is here on the screen? This right here is now, do you see how this used to be a fourth power? This is now 2x cubed plus 11x squared plus 18x plus 9. The power will go down by 1. Okay? So we've just found out that x minus 2 is a factor. Now we're going to do the same thing with x plus 3, but right here, Seth, we're going to use these numbers, not the original. Okay, so we're going to use 2, 11, 18, and 9. So we put 2, 11, 18, and 9, drop the 2, negative 3 times 2 is negative 6, 11 and negative 6 make 5. Negative 3 times 5 is negative 15, 18 and negative 15 make 3, negative 3 times 3 is negative 9, 9 and negative 9 make 0. Can anybody, well actually it's right there on the screen, 2, 5, and 3 is now what? 2x squared plus 5x plus 3, and that can be factored from algebra 2. That's now factorable into 2x plus 3 and x plus 1. So the final function is now completely factored. This is now called completely factored. It's x minus 2, x plus 3, 2x plus 3, x plus 1.
Wait, why is it x minus 2 x plus 3?
Those are the two that we needed to show were factors of the function.
Okay.
But now, this is where I want you to make sure you're paying attention here. The first time we did this, Sydney, we used the coefficients of the polynomial, and we got a remainder of 0, right?
Yeah.
The second time we do this, we don't use the same coefficients. We use what we got. Okay? So we're going to use what we got right here, Abby, for the next division, the next synthetic division. Yes?
So what you did for the 2x squared plus 5x plus 3 is you just...
Right, then we pulled out our skill bag from Algebra 2, and we used what we learned in Algebra 2 to factor that out. Could you keep using the synthetic division? Yeah, if you had a guess as to what another 0 was. Yep, you could use it. Uses of the remainder in synthetic division. The remainder are obtained in synthetic division of f of x by x minus k, where k is a number, provides the following information. The remainder r gives the value of f at x equals k. That is to say that the remainder actually turns out to be f of k. If r is 0, x minus k is a factor of f of x. If the remainder is 0, k comma 0 is an x-intercept of the graph of f. So these two things right here, 2 and 3, are saying the same thing.
Wait, what if you get a remainder that's not 0?
Good question, because that's exactly where I'm going next. What if you get something that's not a remainder of 0, which can actually happen quite a bit? All right, let's say, plug in 1, negative 2, negative 15. Okay, this one right here. So I'm going to pick number 26. And we're going to take this and we're going to divide we're going to take 2x cubed minus 4x squared minus 15x plus 5, and we're going to divide that first. I know it says here on the screen x minus 1 squared. I'm going to divide it just by x minus 1 first. Okay? Now, what would let me set it up, what would the numbers be that I put in here?
Negative 4, negative 15.
And what's the number I put here? 1. Drop the 2. 1 times 2, 2. Negative 2, negative 2, negative 17, negative 17, negative 12. Not a remainder of 0, right? Okay? However, if the function 2x cubed minus 4x squared minus 15x plus 5, if I plug a 1 into this function and calculate f of 1, it turns out that the number I get is negative 12. So the remainder that's right here is the number that I get when I plug 1 into the function. Okay? And that's what number 2 was saying in the textbook when I showed you that box on the screen of 1, 2, 3. Number 2 was saying, hey, if you plug the number in, you'll get the remainder of what you get by division, using the division algorithm.
How would you write that?
Okay, now how would you write that? Now, let's go back. What if you're being asked to find the quotient? Okay, so let's interpret this part right here. How do we interpret this?
2x squared.
2x squared minus 2x minus 17. What if we're being asked to find the actual function using the division algorithm? Okay, well, it's going to look like this. It's going to end up being f of x equals the divisor, which is x minus 1, times the quotient, which is 2x squared minus 2x minus 17, plus the remainder, which was, there we go. Now, if you FOIL out x minus 1 times 2x squared minus 2x minus 17, and then you combine like terms, you'll get the original function. You'll get that.
What if, like, on the problem though, it was x minus 1 squared.
Right.
So, like, how would you do that?
Okay, you'll have to do that in the next lesson because that's long division. Because then you FOIL that out. Actually, no, what you can do, Sydney, is you can divide it by x minus 1 twice.
So you divide by x minus 1, then the answer you divide by.
But we didn't get a remainder of 0, so that complicates matters. So what I would do in the long division problem is I would FOIL that out, and then I would do long division.
Are we going to have to do that tonight?
Not tonight, that's Monday. Next week. Okay? Alright, get with a buddy. Get with a buddy, and let's see here. Pre-calculus tonight. I want you to get with a buddy and actually start on the homework for the remainder of the period that we have left. So I want you to start with number 32. Let's read the instructions carefully together. In the following exercises, use synthetic division to divide. So what you're going to do here, Katie, is in number 32, you're going to find me the quotient. You're going to find me the quotient. Okay?